So my name is Pat Helland, and I work for Adam now, which is kind of cool. I was here a couple years ago when I was not working for Adam, and have spent all my career working in product teams. I spent most of the 80s at Tandem Computers, where I was chief architect of their transaction logging and recovery plumbing called TMF, and came to Microsoft in '94 and started a project called Microsoft Transaction Server, which is now ComPlus. And I've spent most of the last 5 years working on what is now called service-oriented architectures, but really messaging and how we do that. So I've been thinking a lot about the vision of where the world's going, and I'm going to tell you a story called Metropolis. So we kind of fibbed to you and didn't want to tell you the title has changed. And this keynote and the one that follows after the break after this keynote are really two parts of the same thing. Dave Campbell will be presenting the second part, and this is part one of Metropolis. The outline, again, of the 3 hours worth of content is, first of all, we're going to do an analogy called Metropolis. And I think it's very evocative, helps us learn about where we're going. Then we're going to have some practical advice for building services, and then we'll wrap up the first hour and a half. Then Dave's going to come out, and he's going to do part two, and we'll have an introduction, consider data and messaging in services. We'll do some more thoughts on business process, and wrap up. So now let's dig in and look at the analogy I like to call Metropolis. The analogy is that if you look at IT shops, and if you look at cities, right, they have gone through amazing parallels. They grew independently, they were isolated from each other and had their own evolution. And then what happened was they got connected. Cities got connected by railroads. The information technology shops got connected by the internet. So when the railroads arrived, people started moving around and stuff started moving around, and it changed things. And when we've taken these disparate IT shops that have grown up in isolation and we've hooked them together with the internet, people started browsing and stuff started moving, data started moving, and it's changed things. And the real point is that from this analogy, we can get some ideas about where IT is going, because the urban development is farther ahead on the track, and how can we learn and have that guide us towards what we can do as we think about the directions to take information technology. So let's flesh this out. Cities map to IT shops. Factories and buildings map to applications. Transportation maps to communication. Manufactured goods map to structured data. Manufactured assemblies, where you're buying things from different companies and then putting it together, maps to these newfangled virtual enterprises where you're outsourcing part of your company. Retail and distribution maps to business process. Urban infrastructure mapping to IT infrastructure. City government to IT governance. And we're going to dig into the rest of these sections as we go through this analogy. Now, what are the implications of this? Well, one of the implications is heterogeneity happens. Don't let some kid fresh out of college come and tell you to throw out everything in your IT shop and install Windows-based stuff and throw everything else away. That's about as sane as telling the mayor of Boston that his roads are crooked, let's bulldoze and start over, right? So that's the first point. Second point is that there's ongoing IT investment. And you got a problem. Do you put it in infrastructure? Do you put it into the business apps? What do you do? This is a tension that maps so much to what the urban guys are going through. And you have historical monuments to deal with. This edifice that you have in your IT shop, this is an application that's really, really hard to bulldoze, right? And so you have to kind of work around that in figuring out how you're going to evolve what you have. Standardization is nascent. We've got all this web services stuff, and, we actually can shovel the bytes between machines today. It's great. You don't have, IBM's way versus, you don't have to worry about EBCDIC versus ASCII and all of those issues. We can get the bytes back and forth, but that doesn't mean we can do a very effective job of really communicating. The standards are just coming to life. The way we hook stuff together is with people. Those efficiencies just still are coming. Business process. Most of business process is in Harry or Sally's head, right? It's not automated. It's not even tracked very well, much less, magically hooked together. And finally, loose coupling helps investments. We'll revisit this at the end of the analogy. So let's dig into how cities map to information technology. So there's an evolution of cities. We've had gradual growth. People would gather for commerce and manufacturing, but the buildings themselves were independent. There were no connections between the buildings. You know, at first you try to put it by a stream to maybe get some power or something, you know, but you might think about a road, but that was about it. The cities themselves were also independent. Not only were the buildings independent, the cities were. It was a pain in the butt to go and travel. You go back and read what it took to travel 50 miles, and you realize, I'm not going to the next city very often. And you developed independent ways of doing things, independent styles, independent approaches. Neither was right nor wrong, you know. Sometimes it's like Marco Polo going to China, right? It's just different, right? And that's the way things have grew up in cities. What happened in IT shops, right? Gradual growth, you know. The new application, you build it, you change it, you grow it, you add to it, you build it, you change it, and it just gets poured investment into it as it gets larger and more complex. But those apps aren't hooked together. They're not connected very well, right? People interact with them. And the people are the ones who solve the fact that this app does it this way and that app does it that way. The people typically are more adaptable than the darn apps. B2B, very limited. Again, largely by people, and you have independently designed and incompatible apps. So if you compare cities and IT shops, you have big, complex, and evolving environments. The economics are what causes change. This is just not master planned. It's driven by money and how are you going to solve your problems. There is an ongoing investment. You're building new apps or buildings. You're renovating old apps or buildings. And now what are you going to do about the infrastructure? You have to connect these things. Those trade-offs and choices bite you in both cases. And both have historic monuments to consider. So that wraps up the cities versus IT shops. Let's dig into factories and buildings comparing to apps. So if you go back with factories and buildings to the early 1800s, you had really simple manufacturing, independent buildings, and shipping was a real pain in the rear. In the late 1800s, you started getting sophisticated manufacturing, and what you had were autonomous buildings, autonomous factories, but they were interconnected because you hooked them and you put them by the railroads, and that allowed you to have some interconnection. And furthermore, you attached them to the city infrastructure. Things got so concentrated that it was hard to not have sewers and water brought in, and you had to hook stuff up to it. So what's happening? Applications today, they produce processed data, mostly independent, and it's really hard to get any useful interconnection. The IT infrastructure, well, we're talking about it, and we're getting a little bit of progress on it, but it's just emerging. It's just being born. Automated business process, good luck, right? We're sort of kind of there, but not very well. I propose tomorrow we're going to see rich interconnectivity, sophisticated data interchange, and sophisticated business process. And furthermore, these things are going to be tapped into the IT infrastructure. But the key is allowing independence is essential. You've got to get work done without being saddled by the fact that you're talking to someone else. So you have to decouple to allow for that evolution. And yet, there are advantages to the interconnection. It allows you to leverage others. It allows you to leverage services provided by other apps. It allows those other apps to provide demand to you as an app so that you have a reason for existence. It allows you to tap into the IT infrastructure to get your job and to get things that help you do that job done. So it's very important to see this growth of independence and yet interconnectivity. So that kind of wraps that section. Let's look at transportation versus communication. Transportation, the railroad arrives. I've had more fun reading railroad history in the last few years. It's really fascinating. There was money came. People built all these rails to move people and raw commodities. It was wheat and it was coal, right? And that was it. It wasn't manufactured goods that they invested in the infrastructure for. It was moving people around, moving wheat and coal. There were speculations, booms and busts that make the internet one look like nothing, right? It was way crazier. Movement of people changed things. Retail expanded. The movement of stuff changed things because you would get the stuff from city A into city B, and it didn't work with anything from city B. So there was a reason, a motivation to make things standardized. That caused huge change because the stuff had to work together and the retailers had to gather the stuff for sale. Communication. The internet arrives. What do we have? Money in browsing and moving raw data. It's JPEGs and MP3s, baby, right? It isn't your structured data that is paid for all that internet stuff. Chat. Let's not forget chat and email, right? But it's unstructured data. And it's the ability to browse, which kind of transports the person somewhere else, which is funding all of that infrastructure of the internet. People browsing are changing things. You can directly access that remote app, and that is driving the demand for the business process, right? It's really profoundly changed how you think about interacting with an application. The changes from moving structured data, they're just barely beginning. We haven't seen them really take hold yet because the data still doesn't work together very well, and the business process is still very limited. So comparing the two of these things, they both got their foothold by moving people and commodities. That, in turn, the fact that you could do that, drove changes. Standardization of stuff and data, retail and business process are going to change. Retail has changed, business process will change. Economic consolidation. The small town went out of, it just collapsed in the late 19th century, early 20th century. And what you're going to start seeing for us is that IT shops that can cope with standardized data are the ones that are going to remain after that economic consolidation. That's going to be key, is the ability to cope with standardization, to cope with business process. That wraps that section up. Let's look at manufactured goods and structured data. So manufactured goods. In the early 1800s, everything was handcrafted. I like to say trim and shim. You had to like whittle it here and then shove something in there to make that stuff work together. There was a fellow named Eli Whitney. His biography is fascinating. He not only did he invent the cotton gin, but then he also he did a guns manufacturing for the federal government. And he figured out that if he made the barrels consistent enough and the locks consistent enough and the pieces consistent enough, he could put it, efficiently create the parts and then assemble them together. There was a French fellow, I think LeBlanc, who did it, like 30 years earlier, but people kind of forgot what he did. Eli Whitney started it, and America started leading in manufacturing because of what he called his interchangeability system. This barrel could go on any one of these guns, and that was a huge breakthrough. But remember, we're talking inside one factory. The parts were interchangeable across the goods created from one factory. By the late 1800s, you started seeing people doing things assembled from lots of factories put together. You started seeing de facto standards emerging across the industries, so nuts and bolts would work together even if they were made from different manufacturers, because the marketplace demanded compatibility and retailing demanded compatibility, because otherwise you couldn't sell this stuff. So every stinking manufacturer either retooled or they went under. That's what happened. Now, structured data. Today, what do we have? We have non-standard data structures. Every app does it their own way. Mostly human, trim and shim to integrate. I'm sitting and I'm interacting with the app, and then I turn and I type this stuff. Oh, that doesn't fit. I'll change it so it fits this other app's way of doing it. We have the beginnings of standardization. Web services, I love it. I am pleased to not say this is, undermining web services. I'm just saying it's just the beginning. We're crawling. We're just crawling. And we're together going to have to then walk and run. We need industry standards. I believe they will be de facto standards, both horizontal and vertical, more than de jure standards in all of the app semantic issues, but we can have that debate. I hope most of you come and talk to me. My reward for doing this is that you can come to the breakout and actually tell me where I'm full of crap, and we can talk about these issues, right? So that's really going to be how it shakes out, I think. But there's demand for business process today. So soon, I think we're going to get industry de facto standards, increased compatibility, and more sophisticated business process. So comparing the two, you have to connect to other stuff because you can't live in isolation. Manufacturing retooled and new efficiencies in markets came. Apps have to retool. Data and business process integration, and there's going to be a lot of value that will come from that. So next, let's turn to manufactured assemblies versus virtual enterprises. In a manufactured assembly, what are you doing? You're assembling parts from other factories. The only way you can do that is with detailed, gory, fine-tuned specifications of what the parts are from the other places. But if you do that, that means you can pull them together and produce higher value goods because you didn't have to do everything soup to nuts all the way down to the fine grained stuff. Most bicycle manufacturers don't make tires, right? It's just kind of how it happens. Now, what's also cool is once you have those standards, competition drives efficiencies. You get better parts and you get better prices. And we've seen this. And this was the huge change that occurred through the late 19th century and the 20th century. Now we're starting to see virtual enterprises. So what does that mean? You are doing business function outsourcing, right? So I'm going to take part of what makes me, me, and I'm going to have him do it for me. Right? You're seeing some of the delivery companies doing, distribution and transportation. All sorts of things are being outsourced so that you can focus in on what you do well, what your specialty is, concentrating on your center of excellence. Competition is going to drive efficiencies. Instead of just having kind of this department that does shipping, right? You hire the shipping, and if they're not doing a good job, you go to the next guy to do the shipping. But in order to do that, you need data and business process standards that work together. And what's important is to have the normal case, not every case, but the normal case avoid human touch. And it's fine to have special cases requiring human help. I'm not trying to say we failed if 1 out of a million requires human intervention. Just the opposite. I'm saying if we get 20% automated, that's great progress. And it's moving towards that. It's getting there. So comparing the two. Standards allow composable stuff or data. Better stuff or data is created because you're combining the efforts of many different companies. Those increased efficiencies offer lower prices or greater profitability and let the company focus on its specialty. Now we're moving on and we're going to look at retail and distribution and how that compares to business process. This is my favorite section out of the 8, right? By the late 19th century, interesting stuff happened. It's great to read about it. The trains brought people to stores. So the trains would bring shoppers into town and they'd get there, and the stores ran shuttles to the train station, right? So you'd get off the train and you'd go to the baker and you'd go to the butcher and you'd go to these people and you'd hit lots of different stores. And those stores at first were front ends for the manufacturers themselves. It was like the front door is where you sold it, the back door was where they built it, right? And that's kind of how things worked for a while. Then people started realizing I can now use this transportation to take the stuff and take it from where I create the stuff and send it off to stores. And you started seeing department stores emerging, consolidating it, and you started being able to go to one place and buy lots of stuff. But you couldn't do that until the stuff was the same every time. So that required it not being handcrafted. It required that it be standardized. Next, you started being able to send standardized stuff to people with mail order. Well, now, gee, I got this catalog, and it's got a page in it, and it tells me what I'm buying. Well, how can I do that? I can't buy that stuff unless it's the same every time, and then they put it on the train and they send it to me. So that standardization empowered the mail order stuff. 20th century. We start seeing more department stores and more supermarkets, one-stop shopping. Criminy, now we got banks in there and pharmacies in there, and you can get your nails done and everything in this one big supermarket, right? And then Walmart came along. What Walmart did was they said, to heck with you, Mr. Manufacturer, you're not setting the standards. We're setting the standards, and if you don't like it, we won't buy from you. And there was this huge shift in power from manufacturing to retail. And we're still in the midst of all of that turmoil as the efficiencies that Walmart's bringing give them the power which allow them to set the standards. And it's just an interesting phenomena to see. So where are we today in business process? We are significantly behind that. Today, swivel chair integration is the excellent form. So, that saves you actually getting up, right? Because you can turn from app to app, from screen to screen as you do your app integration. Fax and pray integration is the most common form of B2B work. This is how it works. Do you disagree with me? This is the most common form of B2B is fax and pray, right? Okay. Now we've made significant progress. Alt-tab integration reduces errors via the clipboard. Right, because you've got two apps sitting there and you can copy between them. And that's a big benefit, right? So that's kind of the real progress that I've seen we made. But looking to the future, We need data and operations standards, right? We need to have a way of talking about this stuff in a consistent fashion that transcends the applications. As Eli Whitney said, we need interchangeability. I actually feel a lot of times when I give this pitch like I'm standing in the middle of the 19th century and I'm saying, I know what you want. You want clothes that are either a little too big or a little too small. You're used to going to the tailor. You're used to them being spot on, exactly right. And, you guys may have noticed I have challenges with scalable middleware myself. I have to buy these long sleeves and all this kind of stuff. And it's sort of, and I go to a special store, but it's still not quite fitting. But the facts of life are that before we got clothes standards, you didn't bother bathing very often because what was the point? You had one suit of clothes and it stunk, right? And so daily bathing didn't happen until after the abundance of clothing that came from the creation of almost good enough but interchangeable sizes. That profoundly changed the world because it allows for the pre-manufacturing, it allows for the pre-allocation, and when we do this for business process, it can make business process efficient. So, comparing retail and business process. There were amazing transformations in retail. People were very happy to accept standard stuff because it was cheap enough. Customization today is rare and expensive. Now, contrasting that, business process is mostly handcrafted. Poor standards, manual trim and shim, poor interchangeability. I argue business process will grow to drive the apps, just as Walmart grew to drive the manufacturing standards. We aren't there. Business process is so clunky, it doesn't have that energy yet, but it's where we are going. So that's one observation I want to take away, that it will drive the apps as we get there. We're not there, but we're on the way. Okay, next section, urban infrastructure to IT infrastructure. Okay. So you had cities, and they've got to be lots of people, right? And then pretty soon, it smelled bad, right? And so you decided you had to solve that, and you hooked up water, sewer, gas, electricity, broadband. These things required metropolitan support. You had to have the water supply, the dams. You had to have the sewage treatment plants, or at least a place to dump it in the river, right? Something that was metropolitan. You needed all of these services that were metropolitan-wide. But you also needed to hook it up to every darn building out there. Now, retrofit happens. Notre Dame has toilets and electric lights. I've been there, right? And I guarantee they didn't put that in when they first built the place. It's very nice, and I love it, right? And nowadays, when you build a building, you put a conduit in. Right? We don't know what the next cool broadband thing is. Maybe it's based on psychic hotline. I don't know, but putting a pipe out to the street seems like a good idea. So that's what we're doing nowadays because we've seen enough change in infrastructure. We think we have a good chance of getting it through that pipe. So that's why you put conduits in. Furthermore, as we start building this urban infrastructure, we got a problem. Who pays for it? Is it private funding? Or is it public funding? There's this beautiful overpass over there in Northeast 40th, and, Redmond said, yeah, you can build another building, but only after you pay for the overpass. And I don't even object. I'm not saying that. But that's an aspect of the combination of public-private funding tension that occurs within urban infrastructure. IT infrastructure. You got lots of apps, lots of servers. You get the IT infrastructure. Boy, it was easier back in the day. You just had a mainframe, right? And it took care of all that stuff, and you weren't spread out across 300,000 different servers, right? That was a lot easier, but it isn't where we're at, as we have many different machines, many different apps. So today, we struggle with federated infrastructure, federated identity, federated security, federated naming and directory, federated management. These are, and I'd love to hear more of the things that are on your minds when we get a chance to talk. These all are about how do we federate them in a heterogeneous fashion? Because I got all these different machines, and if you think you've got IT shop standards, wait till after the merger and acquisition, right? Because it's not realistic to think you're going to hold to that. Retrofit is going to happen. Now what's interesting, a cool thing about web services is if you fast forward and look at apps built with web services, and we haven't shipped the plumbing all the way so that you can't even be there, but when you do, it's quite credible to talk about some infrastructural needs going by the extensions that you can do to the SOAP messages that are in the web services plumbing. Right? That's quite credible. Now, are we there? No. Are we laying groundwork? Yeah. Does that mean when next building we build, we're putting a conduit in? Yeah. Is it going to solve everything? No. Will it make it easier in the future? Yeah. Funding in IT shop competes with apps. You guys know this way better than I do, right? You know, you're trying to struggle. Where do I put my money? Comparing them. You have infrastructure for crowded environments, needs supporting services, needs hookups to building and apps. Retrofit happens. It may be your biggest cost. It's extremely likely that that retrofit is the biggest cost. And so we're starting to design for future extensions, and we have funding competition. So that gets put away. City government versus IT governance. So how do you decide stuff? Well, you got the city vision maps pretty well to your IT principles. Now, if you go to Bellevue, they've got these skyscrapers. Redmond, they don't want skyscrapers. As a matter of fact, most of the campus has only 3-story buildings. We've got 2 next door that are 4 and 5, and I'm not quite sure what changed, but I know there's building 42 and 43 across the street that are 4 stories on the Bellevue side of the city line and 3 stories on the Redmond side of the city line. There's actually a drop where the city boundary is, okay? It's called city vision. What do you think? Redmond says, you know, we're not a skyscraper town, right? IT principles, you have the same issues. What are we trying to accomplish? City planning versus architecture, city infrastructural goals versus IT infrastructure strategy. Do I invest in factories and buildings? Do I invest in business apps? What are the public-private choices that I have? What are the IT investment priorities and how does it get funded? Does it get funded out of the business group? Does it get funded out of the IT slush fund? Right. Now the stuff on the right I got from Professor Peter Wheel at MIT, so I just want to acknowledge that. City government. You have decisions for allocating resources. This involves city and business leaders, and the infrastructure usually needs cooperation. The decision to build factories is usually pushed by the businesses. Not always, but usually. And the cities usually are the ones to say, whoa, Nelly, you got to do it this way, right? The individual manufactured goods and the decisions behind that, those are usually ones that the businesses make. The city might tell you you can't do a paper mill, but for the most part, you have choices inside the city, inside the business to do what you want to do. IT governance. Who's making the decisions? Is it the CEO, CIO, business unit executives, the techies committee? Who's deciding where you put your resources? What are the priorities? Asset utilization, cost? You know, what are you trying to do? Did it work? What are my metrics for success? Who's accountable? What goals do I have? Am I about reducing cost? Am I about better information? Am I about competitive advantage? How do I decide where to put my resources? The point is, it's the same pattern. You see commonality, and you can learn a lot by looking to the cities for that inspiration. One other really interesting point is if you look, at least in the United States, about how decisions are made. The decisions to build factories and buildings come out of businesses, and the cities usually are trying to just constrain that. And if you take that parallel to the IT governance work that I read out of Professor Wheel's stuff in MIT, that is something that optimizes for growth, potentially pessimizing cost control. Right? So that's how we do cities. Cities we do. That's just kind of an interesting observation. In the United States, we tend to optimize for growth at the expense of cost management. And that's a very interesting comparison when we think about what we want in an IT shop. So that wraps up the 8 sections of the analogy. So let's look to the future. Wow, okay, so what did we have? You know, we had the early 1800s, single factory interchangeability, then the railroad, then shopping excursions, manufactured assemblies, department stores, and finally in like 1986, Walmart came along and said, oh, you're going to do it my way. So my observation is you are here, right? Kind of around the 1880s, something like that. I don't know, but it's kind of sort of, right? Communication and browsing are well established. Virtual enterprises are getting going, but business process is just a gleam in our eye. There's nothing real there. It's just something we can conceive of. There's going to be a lot of fun ahead of us. If you look back to urban development, boy, that was a time to live in the late 19th century. We are in a time to live. It's going to be a blast. Now, Do not take away that I think it's going to take 100 years. I am not trying to tell you that. But the same causes, effects, economic dependencies are at play that were at play with urban development. Same slide I showed you earlier. Heterogeneity happens. Ongoing IT investment, infrastructure versus business, historic monuments to consider. Standardization is nascent, connection largely by people, efficiency still to come. Business process is nascent, mostly ad hoc, but it's growing to become a dominant force. Now, loose coupling is going to help those investments. Okay, so that's the end of the analogy. And that's to try to set the stage and make, so that the rest of the stuff about service-oriented architecture kind of fits in place and you can see why and where and how. Now I'm going to do a really quick change of pace, and we are going to dive into technology. But I know you guys are, the people who can do this kind of stuff, both technology and these big ideas. What we're going to do is dig into the practical advice for building services. So, services versus components. There has been a natural evolution as functions grow to components, grow to services. Services are made out of messages, components, and data. The private data completely gets encapsulated, but the key is the only way in and out is via messaging. So that's the big takeaway, is the services encapsulate stuff, and you only get in and out with messaging. And that's a little different than what we've seen in the component world. But I also want to point out, we're not walking away from all of that stuff we said before. It's the building blocks upon which we get services. Now, services in the enterprise. A lot of your developers who might have gone to the PDC are going to come back and talk about how we're working on services here and services there and services everywhere. And that's wonderful stuff. And making them ubiquitous has a lot of value. Services in the small, services in the large. When you look at Longhorn and web services and services, we are going to be enhancing the programming model. There's going to be tools and frameworks making it easier. And of course, web services is about interoperability. Now, do I think this is a panacea yet? Heck no. But do I think it's great that we can get started by at least sending messages around that we can partially understand as we move up the semantic stack? You bet. I think it's great progress. What I'm going to do in this talk, and what Dave's going to do in the next talk, is we're going to take this service notion, we're going to zoom back and look at it from the enterprise perspective. Talk about how to think about big mama services that are kind of surrounding apps, or maybe are pieces to build an app out of, but they're big. They're not itty-bitty tiny things. And what we're doing is being more prescriptive, yet compatible. So you hear about the Indigo stuff? That's great. But we're saying use the Indigo stuff this way. Or even still, Indigo hasn't shipped. How do you build services even if Indigo hasn't shipped? Okay? And that leads us to the last bullet. This entire set of material, this talk and the next talk, part 2, are platform independent. What we're telling you applies as well to a J2EE environment as it does to a Windows.NET environment. Deliberately focusing on the concept and techniques, because if it's about heterogeneity and hooking stuff together, you gotta have concepts that are platform neutral. So it's applicable across many platforms. What are the challenges with a service-oriented enterprise? Apps have developed independently, purchased or homegrown. Usually they work with humans, not designed to work with apps. So we're going to need services, and we need to surround those existing apps to play with services. Hear me, I am not telling you to throw away your investments. I'm telling you those investments don't play well with others, right? And how can we make that easier is the important thing. What are we going to talk about? Practical advice for building services now. First section, avoiding ambiguity in messaging. What to consider when writing messages to ensure that they are understood by your partner. Because it's really easy to write stuff out there which is kind of confusing when it gets to the other side. Services for the enterprise. What kind of considerations do we have when we take all the services goop and back it up to be enterprise focused for enterprise class applications, which is where I've spent my career. Message delivery in the mean, cruel world. How are you going to connect apps or services with messages. It's got many pitfalls, many failure windows. What are we going to do? I guarantee you, every single message you send onto the internet is guaranteed to be delivered 0 or more times. That's the absolute rules you get out of it, right? You send it, and it may or may not get there, and it may or may not get there a bunch of times, right? It's a matter of probabilities. So you got to cope with it, right? Implementing your business service. Messages, data, transactions. How can we make an enterprise class service work? And how to embrace and extend your apps. You've got a lot of stuff. How are you going to let it play like services? Now, this is just the rest of this talk. There's more coming in Dave's talk. So let's dig in and get into the avoiding ambiguity in messages. Messages are special. Between services is a special place. Because when the messages are sent and they float around in between, it's like going out on a ship in the ocean back in the day, right? You didn't quite know where the heck you were going to get to or what the heck you were going to find when you got there. And so you need special care to understand them because the guy on the other side might get pretty darn confused. Immutable and/or versioned data. So this is just some things to think about in this messaging world. Data might be immutable. It's a characteristic you may have on data. Immutable means once it's written, that's it. I can't change it. It's what happened. Immutable data needs an identifier. And the rule is, give me the identifier, and I'm going to give you back the same bits. I don't care where you ask me. I don't care when you ask me. I'm going to give you back the same bits. That's what immutable means. Here's the ID. Here's the bit pattern. Versions are immutable. Each new version is identified. Given the identifier, you get the same data. So if I give you New York Times for the 3rd of July of 03, I get the same bits. I get the same text on the same page because that's what it was and that's what it is. And if you ask for Service Pack 1 of NT4, I get the same set of bits every darn time. Like it or not, that's what it was and that's what it is. There's also a notion of version-independent identifiers that let me ask for a recent version. So I can say, you got a recent New York Times, and maybe today's, maybe yesterday's, whatever. Once I get it, right? Or I could ask for the latest service pack of NT4. It's NT4, but the results will vary over time, right? Those are both useful concepts, but it's essential to have those differentiated as you design systems. The next problem, the stability of the data or the metadata. Stable is my word as a characteristic, so you're not going to see it in the literature. But I point out that immutability is not enough. You need a common understanding. And if I pick up a newspaper and it says President Bush, it behooves me to look at the date. Because if the date is in 1990, it means a different individual than if the date is in 2003. Because that string binds to a different individual based upon when you interpret it. Stable data has a clearly understood meaning. So I got to understand the schema. What does it mean? What's in the contents of this? And I got to interpret the values in an unambiguous way. So a little piece of advice is don't recycle customer IDs. Because if customer 425 means a different company today than it did yesterday, that's bad, right? That's not stable. Observation. A monthly bank statement is stable data. It is what it was, and I understand it, and I'm not confused. Another observation, it's a giveaway if the phrase current is in the name of the data. That is not stable stuff. It's useful, it's just not stable, right? I'm not saying current is bad, I'm just saying it's not stable, right? And I actually don't think you should use the phrase current in anything flowing around on the internet because it doesn't mean squat by the time it gets there. You have to date it and timestamp it. It's not current, it's Tuesdays, right? That's what you can send out. You can't send current out. That's part of what I'm trying to point out. Suggestion, timestamping or versioning makes stable data, makes data stable. Normalization. Now, I was raised at the altar of normalization and serializability. I'm a transaction guy, I grew up believing there is serializability and there's evil and there's normalization and there's evil. Okay, and this is how I was slapped around when I went to school and I was raised, right? And the point is you design your databases for normalized behavior so you can change it without getting funny behavior and put each data item in exactly one place. The point is, sometimes data should be denormalized if it's read-only. So here we have one of the 3 extant databases from the 1970s. It's the employee database. There were only 3. There was, states and employees and one more. Classic problem with denormalization. So here we have Joe works for Sam, and here's Sam's phone number. The manager's phone number is in Joe's employee table. And Pete works for Sam, and so Sam's phone number is repeated. Classic normalization challenge. The point is, that's really important not to do if you're changing the phone number. But if you're writing a bunch of immutable data, to heck with it. It's not a problem to have it denormalized because it's not a problem. Next issue, to cache or not to cache. It is okay to cache immutable data. You say, I want this, and you give me here's the ID, you get the same bits back. It's not going to screw up. It's okay. It's never wrong, never have to shoot down the cache. You should consider the stability so you don't get confused. So now messages are easily cached because they better be immutable or stable. Reference data, the ability to push data around that someone can read at and look and stuff, that should be versioned, with the version being immutable. Some data should just plumb not be cached. You just shouldn't go there, because if it changes, it might be out of sync, and if you have timing windows, that's bad. So you should always cache immutable data and not other data. Validity of data. It's okay to bound the time or the space in which the data is valid. You can bound it with valid times by having an expiration. Here I've got price list valid until December 31st, or offer good until next Tuesday. Those are great ideas. You can bound the locations. Offer good to Washington State residents only. Data valid for this service only. You can only use it on these 2 servers. Those are all legitimate concepts. But when the data is valid, the data should be immutable, and it should be stable. So immutable, the same ID, the ID yields the same bits. Once you get the bits, you ain't confused about what they mean. Within those bounds. If you're outside the bounds, that's okay. So rules for sending messages, for sending data in messages. First, identify the message, put a unique ID in. Part of the ID may be a version. That's fantastic. Versions are a cool way. Immutable data. Don't ever change the data associated with the ID. Never, ever return different bits. It's okay to cache, because it's immutable, it's okay to cache, because you'll get the same bits back. Define valid ranges. Valid for a certain time period and over some spaces. Now, I am not objecting to having data that is always valid. I'm just saying you have to think about it. You have to say this data is always valid. And finally, it must be stable. You have to ensure there's never any confusion about the meaning within a valid range. Okay, now we're moving on to services for the enterprise. Services and business services. So services give you a name for messaging. That message is going to target the service. So you're going to hear a lot in Indigo, you're going to hear a lot about in Longhorn, how we have this notion of service. And that is a namespace, and it's a way of saying, over there is where I want this to go, and he's going to talk to me, and we're going to do work together. So that service really is a lot about naming and about the end point to which a message is delivered. I'm arguing enterprises need that and more. I love that. I'm just saying they need more. You need what I'm calling a business service. Now, the business service might project multiple names, multiple services. But it's going to encapsulate database resident data. And you're going to implement it with business logic that imposes your business rules. Business services are a prescriptive usage for the generality of services. They comply with the general mechanism. It's okay. Web services, I love it. That's fine if you want to use that for your interoperability standard. I think that's fine. But it's okay to use some other mutually agreed protocol. The point here, though, is you need to completely encapsulate a bunch of data. So that's going to surround it, and it's the only way in and out is through business logic and through the messaging that invokes the business logic. Messages are going to contain operation requests, so you perform a business function, operation responses that describe the outcome and provide any results. process data. So sometimes I'm going to, out of my service, I'm going to emit data that I have chewed up and I've massaged for public consumption, kind of like press releases from the White House, right? It's, meant for external consumption, right? So sometimes you export for data warehousing. There you're sending it to a trusted partner. So again, to emphasize, what it's about is encapsulating data and never letting it in or out unless you've done it in a conscious fashion. How am I going to store it? I should use SQL to store that data. I don't need to tell you guys why SQL is the right thing to do. It just plain is. It's the real thing. Data is going to live in a set of partitions in a set of tables. Let's dig into this. A set of tables. Business services are going to implement the set of services. Each of them needs a bunch of tables. You add together all the bunch of tables, and you got a set of tables. Now, it could be I don't do every keyed record in those tables because I might do geographic partitioning. I might do other forms of partitioning of the service. But either way, I've got a bunch of tables, and I've got slices of those tables into partitions, and I'm going to wrap it up behind some business logic and only let you in and out via messaging. So each business service, now this, I want to hammer this point. Each business service should live in a single database engine. I shipped the second two-phase commit protocol in an industrial product, right? And I think it's marvelous technology, but we are now in a world of trust boundaries, right? And you're building services to be distrusting, autonomous things. And it's atypical, very rare, that you're actually going to try to change multiple database backends in order to do a single service. Service composition and service-oriented architectures are about allowing the loose coupling of the interaction between them. So the data for a single service should reside in a single database engine. Now, I'm not trying to tell you can't put 5 services into one engine. That's fine if that's what you want to do. But I'm trying to tell you one service should sit in one engine is a practical piece of advice. So business services are services. So when you look at it from the outside, you can't tell. Sometimes I like that cartoon which shows the dog typing at the terminal, and he turns to the dog next to him and he says, on the internet, no one knows you're a dog, right? And that's what it is here. You don't have to know this is a business service. The fact of the matter is you've made it industrial strength by the rules that we're talking about. You can build a business service as a composite. So that means it looks like one service from the outside, but inside the belly of it, there's a lot of different services, perhaps on many machines. This is essential for scale-out. This is how you make it work, right? But it has to look like a single business service from the outside, and behind the curtain, you've got multiple services implementing it. So how do we do the scale-out trick? How are we going to make it work so I can actually take this service-oriented goop and run it across a lot of servers? Because that's what I want to do. I don't want to buy a big N-Wave free uncooled puppy, right? I'd really rather buy some of the less expensive stuff and buy more of them. So the scale-out trick is to do load balancing across a bank of compute engines and partitioning across a bank of database engines. And if I have a multi-message conversation, what I do is I remember the earlier messages in the database. So what matters that I hook back up to the correct database, more to find the right partition of the database. It doesn't really matter that I get to the compute engine. Now, I may have a centralized backend. You see this pattern all the time. I shop at some online shopping site, and I've got a shopping basket, and I'm adding stuff, and I'm working, and I'm working. Those shopping baskets and that information about me, that's partitioned like crazy. When I push submit, it goes from the bank of front-end machines off to the centralized back-end one to find out if I can really buy the stuff, and if my credit card's okay, and if shipping works. And then it probably sends me back a stinking email because we don't know how to send answers back other than that. And that's a very normal pattern. So here, you see a big mama service projecting service behavior to the outside. Now I got business logic that is just clones, right? And I got 4 of them here in the picture, and I could shoot one of them, and I only have 3/4 of what I did, or I can add more. They're just compute engines. And I have a SQL database which has got the state, it's got the shopping baskets, it's got the information from the previous interactions. And it's partitioned A through J, K through Q, R through Z. That business logic, it's got database connections open to all of them. You know, the combinatorics are not too bad to support that at all at where we're at. And I have a back-end server that's got logic protecting its own database, which is really doing the real ordering and the real work. That's the real important part in the back end. And I'm going to hook those two together with service-to-service messaging, right? And so I'm going to take messages from the database in the front-end guys and make sure they get to the database in the back-end guys and then process the work. What's the point here? I can have, it looks like business services around SQL. SQL is the soul of the service. The essence of it is that business service. So this picture now looks a lot like that one big service composed out of a lot of little services. But it's really about the database being the core of where changes occur. So now we're going to move along, and we're going to talk about message delivery in the mean, cruel world. So the first piece of advice, which may seem surprising from a Microsoftie, is use whatever kind of messaging you want to. Do what makes sense. You guys have practical decisions in your enterprise. Think about it. Make a good business decision. There's a lot of messaging kinds. Email, IP, TCP/IP, HTTP, MSMQ, MQ series, lots more. They have a lot of advantages and disadvantages. The top three, my opinion, HTTP, MQ series, and email. Why? Because they're the closest to ubiquitous you're going to find. You guys agree with that? I mean, they're more there than anything else right now. And ubiquity is what it's going to take to try to hook all this stuff together. Personally, I think HTTP is probably going to drive forward and drive home. But email is fascinating. And for some people, you know, MQ series is running on a lot of platforms. Ubiquity is essential. You have to connect within your enterprise. You have to connect to your partners. And if you can't do that, the jig's up. You can't even get started on all the other hard problems we're going to talk to you about. The next point is really interesting. It's okay to have some message loss. Because the facts of life are that the guaranteed message delivery, if it doesn't guarantee that the app got it, isn't going to help you a lot. We're going to talk some more about that in a second. What is guaranteed message delivery? Guaranteed message delivery means that the message gets to the queue or the sender gets told that it didn't get to the queue. MSMQ offers this, MQ series offers this. It's a fascinating technology. It's cool stuff. But what you really need to know if you're building complex services is that the service, the destination itself, processed the message. And by the way, was it happy or was it sad? Right? Because if it was sad, you might have to do something different about it. Right? So you need to know the response to the message. The service got it, the service processed it, and what the heck happened. Knowing it's in the queue isn't enough. Once you realize that isn't enough, you start thinking about different kinds of messaging. If I had more time, I'd present more on reliable messaging, which is a web services standard, which does address this issue and does talk about did the destination service get it. But the reality is we're a ways away from that, and you guys have real-world problems today, and so here I am talking to you about what you can go home and start working on today. I think you should track it. I really think you should look at web services, reliable messaging. I think you should look at web services in general. But you got to go home and get some work done, right? And you're in trouble. And when you're up to your ass in alligators, it's tough to remember you set out to drain the swamp, right? And so, idempotence. So now we're going to get into some of the tricks you better think about. And I'm not talking about those ads you saw on TV when I talk about idempotence, right? That's not what I'm saying, right? What it means is requests get lost. Remember, every time you throw a message into the internet, it's going to get there 0 or more times. So the only way to deal with that is to retry. To, throw the message, throw it again. Well, requests arrive more than once. Those pesky retries might actually get there. And that's bad, right? Because then you don't have to deal with it. Idempotence means it's okay to arrive multiple times. As long as the request is processed at least once, the correct stuff happens. In today's internet, you got to design your request to be idempotent, or you have a thing called a bug, right? And that's bad. So let's look at some of these. Sweeping the floor is naturally idempotent. If you sweep the floor 5 times, you have a clean floor. It's okay, right? Not idempotent. Baking a cake starting from the ingredients. If you try to do it a second time, it doesn't taste good. Naturally idempotent. Reading record X. You say, but I got a different answer the second time I read it. But you're on the other side of the curtain. You don't know. You just want to know any value that X has between when you issue the request and when you get the answer back. And so if it's moving, any of those values are okay. And as long as the read of X has no side effects, it is naturally idempotent. It is idempotent to bake a cake starting from a shopping list if you don't care about the money. You go to the store, you buy the stuff, you bake the cake, and you get a lovely cake. You know, and if you don't care about the money, that works just fine. It is not idempotent to withdraw $1 billion. Withdraw $1 billion. Withdraw $1 billion. I mean, it's just, there could be issues with that, right? It is idempotent to have an algorithm which says, if you haven't yet done a withdrawal labeled XYZ for the withdrawal of $1 billion, then do a withdrawal for $1 billion and label it XYZ. That is idempotent, and that is a classic trick that people use. Now, that's not the only challenge you're going to have. It gets even messier. Because any request, any message may arrive after multiple times, even after a long while. The best way to think about this is think of the internet as a bunch of Machiavellian gnomes that are recording every message that's ever sent and re-injecting it at precisely the worst time for your application. That can be very confusing on your app. So here you see, you send A, you send B, you send C. What comes out is A, then B, then A, then C, then A. I hate it when that happens. It's just tough to design the service for that. It's just tough. So, one way around this is to use request response coupled with idempotence. You can actually ensure the processing occurs in order. Here's the trick. Make each request idempotent. That way, retries won't matter. Use request response pairs. Each request submitted has a matching response. Then you implement a timeout and retry, and if you don't get a response, try it again. This works. Request response with idempotence works because even if you're over flaky messaging, the response comes from the actual honest-to-God service. You know what he thought about doing that work. Much better than the classic guaranteed messaging. But request response can be constraining. I'm not trying to dispute that. But I'm here to say, what can you do without platform help? When you see WS reliable messaging, when you see the Indigo work for reliable messaging, when you see the Yukon SQL Service Broker, they make a lot of these issues easier and they make it a richer pattern than simple request response. But if you ain't got it, you got to get the job done, and this is a trick, right? And so that idempotence can be a difficulty, and in a minute we're going to talk about another trick that actually makes it easier on idempotence coming down the line. So what do? How do you deal with statefulness and multi-message interactions? So I send a second message. I send a third message. They are related to the first message. How do I clean that up? How do I associate them? How do I remember data across them? So we're defining a conversation as a set of related messages. The request flowing one way, the response the other. So you consider request-response pairs, and richer patterns are harder. And I also want to point out there may be many ongoing conversations, each kept in a separate database. So here we see request 1 going and response 1 coming back, and only after the guy on the left gets response 1 is he willing to send request 2. And if the guy on the right knows enough to ignore the ones, if he's already seen that number, now we've got that a little bit more organization put and then the chaos that we had earlier just sending messages. So now we're moving on to the section called Implementing Your Business Service. As I mentioned earlier, inside the service you have service private data. Lives deep inside, surrounded by business logic, but you keep it in the SQL database for safekeeping. So here we see SQL in the belly of the service, and we see business logic in the belly of the service. So that business logic is going to surround and protect the private data. It's going to only let changes through that are approved by it. I don't know what it's like for where you guys live, but I know here in the States when you go to an ATM and you start punching things in, they don't let you have an ODBC connection to the back-end database at the bank headquarters, right? It's not what they do, right? There's like 5 choices, right? You can move money, you can look at things. They're very narrow about what they let happen. This is a seminal concept behind services. It's very narrow. It only lets you do the things it think of, right? And it makes sure those are okay. The message comes in and it stimulates work. The logic changes the data, the logic generates outgoing messages, and then you wrap all of that in an atomic transaction, a classic database transaction. Consumes the incoming message, makes the changes, generates the outgoing. The cool thing about that is if it croaks halfway through, it puts the message back in the queue, transaction undo, and then you try again after you come back up. It works really well. But now you say, I got a bunch of services. How am I going to get work done across those services? And I'm going to talk about some beginning concepts, and Dave's going to talk a lot more about this stuff. Because distributed transactions have challenges. They have performance challenges, and they have autonomy challenges. It's like, I don't want to hold locks till you tell me I can let go of the locks, right? There's this intrinsic challenge between consistency and availability in a distributed environment. And the thing to remember is two-phase commit optimizes for perfect consistency. Or loosely translated, two-phase commit is the anti-availability protocol. And that's its goal. Its goal is to say, I'm not going to change that because I don't know what he says I'm going to do, right? But that's not what you want in this loosely coupled world. It just doesn't work right. So how are you going to do long-running business operations? You're going to do multiple transactions over different business services. You're going to do multiple transactions over the same business service, and you're going to hook them together with messaging. So here we have a customer service, and we have a purchase order service, and we have a credit check service. And the customer says, I want to buy some stuff. And he does transaction T1 and he sends a message. The purchase order guy gets kicked. He goes, oh, I got a message. He says, okay, I'm going to do transaction T2. Well, let's find out if his credit's good. Is he a flake? And the credit check guy says, nah, he's okay, and he sends the answer back. So the purchase order guy says, okay, maybe we'll do the work. And he does a separate transaction. And he comes back, he says, yep, we'll sell you the stuff. And the customer finds out. Between T2 and T4, there's no magic. You unlocked the database. If somebody fiddled with some stuff, somebody fiddled with some stuff. In Dave's talk in part 2, we're going to dig into why that's actually not a big problem if you design your app correctly. It really typically isn't such a big problem in spite of what the theoreticians have told you, right? There's tricks to make it pragmatic to just unlock the thing and come back later on with the next message. And we're going to dig into that even more. But I'm not trying to tell you there's magic here. You've just unlocked it, right? Maybe the system crashed and came back up. That's okay, right? It's going to happen. Read-only requests. Read-only requests are idempotent. You can read, you can reread, no problem. Any of the answers are just fine. You have a choice, if you want to, not to record read-only requests. There are some people who say, oh man, the performance on that would be horrible, recording a read-only request. That would be horrible. No, I'm a transaction guy, and I know that you've got a log, and that when you do some logging of stuff, you just write and CRUD in memory, and 50 or 100 times a second, the database is going, and that log's taking the write out to disk anyway. And I actually know, I would disagree. I think it's frequently just fine to remember and log the fact that you processed a read-only request. So I take issue with those people who, as a sweeping statement, say you can't have that performance. No, that it's a performance problem to do that. Now, don't get me wrong, there's some cutting-edge, crazy people for whom it might maybe be a problem, but it's rare. Most of the time you can afford to remember what you read and remember that you did it. Now, Most businesses want to log it for business reasons. You know, you've got all this new regulations coming down your back, which are a pain in the tush, right? This is valuable data for analysis, and you can use that initial read to set up that conversation I talked about earlier. So it's going to turn out we can start with a read that gets us going, and then now it becomes easier to magically get idempotence in the second and third and fourth message. Building a conversation for multiple messages. The conversation can help with that correctness. You can ensure automatic idempotence, not of the first message, but of the second or third or fourth message. Not of the first because it might get rerouted to another back-end database and repartitioned somewhere else, and you might do it twice, right? So that's an issue. You've got to make sure you set it up, and then you can go for the gusto. So once you've done that, the subsequent messages can change data and know that it's automatically protected. Furthermore, this correlates messages with data. Later in Dave's talk, he is going to talk about, you know, having the activity-oriented data. And you can key that off of this stuff. And he'll introduce that activity-oriented data is about doing a long-running operation. By correlating the messages in the data, you are allowing that you can remember that data so you know what to do with the subsequent message. Conversations have to be long-running and durable. I know you guys know this. You got to be able to shoot the machine and bring it back up and not have bad stuff happen. It's just part of the gig. It's what you have to do. So they've got to live as records in the database. Now what these conversations are going to do is connect business services using the SQL database as the conversation storage. So how are we going to do this? We have conversation IDs. Any unique number, cannot recycle them. Sequence numbers get incremented for each request. So the target service is only going to accept the next one in sequence. That makes sure you can't process it twice. The conversation itself provides idempotence. It's never going to do message 3 more than one time because it says 3 and it already did 3. So it's going to say that's nice and not do it again. The responses match the sequence of the request. So the response cannot be processed twice. The responses also are idempotent. So I get it back, and I know, because I've got a sequence number, that it's the response. I know not to take the answer and process it twice. But what I got to do is I got to remember the response so I can retry it later. Because the retried requests sometimes arrive. What happens is I send a request, it does the work, the response gets lost. Timeout, send the request, the response gets back to me. What I need is I need that target service to magically regenerate the response without doing the work twice. How's he going to do that? He's going to do that by remembering the response associated with the request. So when in comes a request for number 3, it's going to send the response back, even if it already did it. I don't want to do the request a second time, just want to regenerate the response. So I better remember it in the database. Now, how do I transactionally protect it? Processing that message should be atomic. I can't partially process it. It is okay to do the work, record the response, and then crash. Why is that okay? He's going to try again. I'm going to look and I say, oh, here's the response, and I'll send it out. But it is not okay. It is not okay to do the work, send the response, and then before I record the response, crash. Because then if it comes back at me again, you know, or I might not do it. He might think I did it and I didn't do it. So that is not okay. So I have to commit my memory of the response before generating the response. So I always have to wait to send the response until after it is recorded. Summarizing this section, it's all about the messages, baby. That is what it takes to build a business service. It's about the messages in and the messages out, and everything else is an implementation detail. Sort of. It's all about the data, baby, because messages are data. Work happens by changing the database. It's stimulated by messages. You change the data, you record the outgoing responses, and that business service itself, the essence of it, lives in the database. Okay, so now let's go on and talk about embracing and extending your existing app. What are the goals for wrapping an existing app? As we discussed earlier, most apps are used by humans today. People know how to make them work. People add judgment to fit those circumstances. What we want to do is reduce the need for people to use the app. This increases the time that the machine-to-machine works okay. The goal, again, is not to eliminate people. That would be great, but we ain't going to get there. Not while you and I are on watch, right? The goal is to reduce the probability. 20% would be how many, tens of millions or billions of dollars? It'd just be phenomenal amounts if we could do a 20% reduction. So just look for that low-hanging fruit. And we're going to wrap the app to look like a service to increase the service-to-service app work. First problem we got is we got to get into the app. How do you get into the app? HTML, 3270s, 3-tier, 2-tier, EDI, MQ, I don't care. How do the people get into the app? How the people get into the app is how you need to try to get into the app. I love screen scraping. I love HTML parsing. Go with God. It works great. And you didn't have to find somebody who, nobody works on the app anymore. Nobody works for the company who remembers how the app works anymore. If you can screen scrape, go with God. That's fantastic. Sometimes, though, it's hard. Client server needs code changes. That is especially hard with 2-tier. I am not going to stand over here and tell you to do mouse over scraping. That is not a good idea, right? I'm not, but some of this is pragmatic and some of it is not. So you want to tap into the app so you can pretend to be a human. Now, the next thing you want to do is you want to identify the idempotent sequences of operations. Oh, yeah, okay. Well, what do I mean? Every app deals with failure. People have procedures. They know what to do because, they repeat these procedures until they get success. It's ad hoc. You want to find the idempotent sequence. That's a set of operations. Each separate operation itself is not necessarily idempotent, but the entire sequence is. So here we deposit $1 billion. We crash. We restart. Okay, now what are you going to do? You look to see if the deposit happened. If not, you deposit $1 billion. That is an idempotent sequence of operations. Right? That is what people do. This is how every app has this kind of stuff. You need to identify it. Then, once you identify it, you define messages and sequences of messages that can map to business operations, searching for the idempotents. And then you create a front end for this app that can play services. I'm a service, right? And you get the message, and then you go and you do what it takes to make the app work, and then you send the answer back. And that's what it's going to take these historic monuments and let them play in the new world. So let's wrap up part 1. Envisioning that service-oriented enterprise, which is the title that you thought you were coming to hear, right? Services move us forward. There are lots of islands of app code. Services are connecting those islands. But independence is essential. You've got to let the services evolve independently. You've got to decide if you're going to do build versus buy. You have to make these things work inside your company and make them work across companies. You're connecting your disparate apps is what you have to do. You've got to make these things work together to move forward. And it's also important to hook in the partners. I like to say that services cleave your applications. I love the word because it's its own antonym, right? They cleave them apart into independent pieces, and they cleave them together by allowing the interaction across those pieces. Now a word from our sponsor, right? There's some cool technology coming. Web Services defines really cool interoperability standards. That's all I'm going to say about it. You should look at it. Indigo, development tools and frameworks for services. Cool stuff coming in Longhorn. You should look at it. The Yukon SQL Service Broker, that's a project that I helped start. What it does is integrated messaging into the database, automatic support for conversational messaging, even richer full duplex behavior than the request response I told you, and transaction protected reliable messaging, very high performant. You should look at it. It's great technology. Now, some of the limitations on that are that it's only SQL Server to SQL Server, so is that going to be something you can use for your partners this week? Probably not. Are there cases where it's useful? You bet. In part 2, after the break, Dave's going to talk about 2 sections, considering data and messaging, and then business process. So in considering data messaging, the space between the services, what goes in those messages, what are the semantics that have to be considered, the schema between the services, what's different, what about different understandings of data, why is XML such a big deal, why is it cool, service agents and service masters. How does data get used inside a service? What are those patterns that can be leveraged? And we're going to introduce data usage patterns and talk about the characteristics of that data usage. Ownership of data in the enterprise. If you can change it, only one service should be in charge. How the heck are you going to make that work? Representations of data. XML, SQL, objects, you hear all this crud. When do I use? What do I use? How do I use? Why so many choices? Why are there religious camps that are fighting over each other and wanting to do things differently? Sometimes I want to write a book called The Joy of Sects, because they're just always in there fighting and competing. Tying it all together. Where do these technologies get used properly? Part 2 on business process. Interacting with services. How do we reach agreement without transactions that span services? How do tentative operations get applied to service masters? What about service agents? The power of uncertainty. It's really cool to look at what happens when you don't know and when you know what you don't know, right? You can manage those shared resources and keep track of what you don't know and manage that uncertainty. Schema, contracts, service level agreements. It's all about the black box behavior. How can we define that? Wrapping existing apps with business process. Humans make long-running work happen. How can we make this driven by services more often? Gets deeper into the semantics than what I talked about. Layering for business process. Taking those service agents and pulling them back to manage that business process in a way that allows for composable business process. And finally, extrapolating from retail and distribution. As we discussed at the beginning of this talk, looking at retail and distribution tells us a whole bunch about the composability of business process. And how do we see that taking us in the future? How can we think about leveraging those concepts as we try to solve dealing with hundreds of apps and having business process spanning them? Finally, build your services now. We're investing a lot in services. Web services is cool. Longhorn is going to make it easier, but don't wait for it. Right? Just to heck with it. You don't have to wait for it. It's going to be easier in Longhorn. It will be. But your business needs services. There's guidance out on the web. And we want you to invest now in building services to separate and connect your apps.